All right, hi everyone, and welcome to the final homework review for Unit 8. We're going to walk through Part 5, the Target 23 Part 5 homework review, and as always, these deal with 3 problems from our Part 5 worksheet. The 3 problems we're going to go through today are problem number 3, number 6, and number 9. And so let's just get to it. And the biggest reason why I want to talk about number 3 was just because of this direction. So let's find the perimeter of the shaded figure. And so this time we just need to add up all the sides, right? We did a lot of work with area in the notes, but we're going to challenge you and talk to you a little bit about perimeter as well in this on the worksheet. And so let's talk through a perimeter problem. And so what you need to see is this is a combo figure. To me, it looks like it is a rectangle. I'm just going to call it a rect and a half circle. So remember what perimeter is. Perimeter is all the distance around a shape. And so we need to add up like all this distance. And what I mean by that is, see this line down here? It's important to us specifically to find the perimeter of that half circle, but we're not going to count it as we are actually adding perimeter of this shape because it's not outside, right? And so we just want to add the outside distances around to find the perimeter. And so a couple things. First of all, with the rectangle, right, opposite sides of a rectangle are the same. So if that top is 17, the bottom is 17 as well. And then if the left is 10, then this whole distance here, which is the diameter of my half circle, is going to be 10 as well. Now, one thing we probably need to remember is what's the formula for the perimeter of a circle? Perimeter of a circle is also called circumference, and circumference is going to equal pi times diameter. Circumference is going to equal pi times diameter. And so we've been working a lot with pi r squared. Now that's the area of a circle. But in this problem, since we want perimeter, we want to work with the perimeter formula. For a circle, it's called circumference, and it's pi times diameter. Now, we don't need to take too much time to work on the perimeter of the rectangle. It's already set. 3 sides are on the outside, so 10 and 17 and 17. So let's take some time to figure out what's the distance around this half circle. So the distance around a full circle is pi times diameter. So the full circumference is going to equal pi times 10 because our diameter is 10. And when we type pi times 10 into our calculator, and then, pi times 10 into our calculator, let me do that real quick. 10 times, where's the pi button? Pi, 10 times pi equals 31.4 roughly. Now, remember, that's the full circumference. So that's like the circumference if that circle was a full circle, but it's not, right? It's a half circle. We don't want to count this left half. We only want to count the distance around half of it. So if the distance around the full thing is 31.4, then the distance around half is 31.4 divided by 2. And so if we just quick divide that by 2, we're going to get roughly 15.7, and 15.7 is the distance around this curved half circle. And so now we can do our perimeter. Our perimeter will equal a 17 plus 10 plus the other 17 plus this half circle perimeter, which is 15.7. And when we add all of those together, we should be getting 59.7 inches. And there's our perimeter of that composite shape. All right, now in number 6, they want the area. They want the area. And so in number 6, the way it looks to me is the green thing is a square. I know it's a square because of all 4 of these little tick marks, right? So if the top is 12 and those 4 tick marks tell me all sides are the same, all 4 sides are 12. And so what's happening is, right, we want the shaded. The green is the shaded. And so we're going to need to do a square minus these 4 little circles because the circles are not shaded. And so let's organize this. Let's find the area of the square. Area of the square in this problem, we can think of it as like base times height, which is going to be 12 times 12. And so that equals 144. Now that's the total. And right, we're going to want to subtract out the area of 4 circles. Now, we had a problem similar to this in our note packet. So let's talk about circle here. And let's just talk about one circle for now. See this side here is 12, right? What if I moved that side up to be right here? That would be the exact same distance, except for, remember, now I've drawn it as diameters of my circle. And so since there are 2 circles that make that up, if I do 12 divided by 2, it tells me that each diameter of my circle is 6, right? Well, real quick, let's review the area of a circle formula. It's pi r squared. And so right now we know our diameter of a circle is 6, but we need our radius for our area formula. Remember, radius is half of a diameter, so our r is 3. And so if we type into our calculator pi times 3 squared, it's going to give us the area of just one of these circles. The area of just one of these circles. And let's start with that. So again, if we type pi times 3 squared into our calculator, we are going to get 28.3 roughly. But remember, we don't want one circle. We need 4 circles. And so if we want 4 circles, we want to take that 28.3 and times it by 4. And so when we times it by 4, we get that all 4 circles take up 113.1. And so then our total for this problem, and I'll try to squeeze it in here, is going to be the square number, which is the biggest green piece, and then subtract away our 4 circles. So 144 minus 113.1. And when we do that, we are going to get 30.9, and the units are centimeters squared. And that is our final answer. All right, beautiful. Now, we got one more problem left. We got a little bit of time, so let's finish it off. Find the area of the shaded figure, round to the nearest tenth. And so there's actually quite a bit going on here. First of all, I think it's relatively easy to visualize. We have a big circle, and then we're taking out a triangle. And so we need to find the area of those 2 things, and we'll take the circle piece minus the triangle piece. So let's start with the circle. Remember, area of a circle is pi r squared. And so remember, we need radius. Right now, you can see that part of our triangle is actually the diameter of our circle. And it looks like to me that the diameter is 32. So my radius is half of that, which is 16. So the area of this circle is going to be pi times 16 squared. And so let's real quick go to our calculator. We'll go pi times 16 squared, see what that equals. Second pi times 16, that's 6, 16 squared, enter. And that says 804.2. And so this circle is 804.2 for its area. Remember, we'll bring in units in just a second. As you can see, they are inches. All right, now that's the whole circle, right? But they've taken out a triangle chunk. So now we got to talk about the triangle. And remember, area of a triangle is base times height divided by 2. But the trick is your base and your height have to make a 90-degree angle. And so here's our 90-degree angle. So I would say our base is 16, but we don't know our height. We don't know the side that makes that 90-degree angle with our base. But we do know the third side of our triangle, which is our hypotenuse. And so we can do a squared plus b squared equals c squared to figure out our height. Remember, the crucial part is labeling the hypotenuse as c. So that's what 32 is. And so our equation here will be h squared plus 16 squared equals 32 squared. And now we got to solve this for h. And so 16 squared is 256. And that's going to equal 32 squared, which is 1024. We need to get h by itself, so let's subtract 256 from both sides. And that gives me h squared equals 768. And then we will finally square root h squared, square root 768, to get the actual value of h, and that will be 27.7. So perfect. Now we can find the area of this triangle because our base is 16 and we just solved for the height right here. And so the area will be base, which is 16, times height, which we now know is 27.7. And then remember, we do have to divide by 2. And so the area of this triangle, when you type that into your calculator, is going to be 221.7. And so our final answer will be, when we take our circle, so our total will be our circle, which is 804.2, minus the triangle, which is 221.7. And when we do that, it looks like that equals roughly 582.5. And now we know the quotations mean inches, so this would be inches squared, and there is our final answer. All right, everybody, that is the last homework review of Unit 8. And so go ahead and move into your practice day. Let's practice part 4 and practice part 5 here. Please let me know if you have any questions, and I will be glad to help you out. Keep up the great work as always. I'll talk to you soon.